Hey, you are welcome. Today we'll discuss the concept of acidity and basicity, and in this context, we'll solve the question which came in GATE 2021, the least acidic compound among the following. So, what is the acidity? Let's say AH is an acid which dissociates as A minus and H plus and forms an equilibrium. Now the equilibrium constant Ka equal to the concentration of A minus into concentration of H plus by concentration of AH, that is the acid. Now higher the concentration of H plus, higher is the value of Ka and higher is its acidity. So higher the value of Ka, higher is the acidity. As well as when it will be higher when the concentration of A minus will be higher in equilibrium. So if the A minus is a stable one, then the equilibrium will shift towards right, and as well as the value of K will be much higher. And A minus is called the conjugate base Cb of this acid. So the higher the stability of conjugate base, higher is the acidity. Now we will discuss the acidity of this MnO and P. So the conjugate base of these four compound are, let's say, M prime, N prime, O prime, and P prime. Now you can see here that the negative charge in M prime is on carbon. On the other hand, the negative charge is on oxygen in these three. So as the oxygen is much more electronegative than the carbon, so negative charge is much more stable when it is on oxygen than carbon. So M prime is least stable among the following. So as the conjugate base is least stable, so lesser is the acidity because the equilibrium constant Ka will be much less. So M is the least acidic among the following. And so the question, the least acidic of the following compound, this is M. The IA will be the answer. Between N, O, and P, we'll see which will be the order of acidity. Now between M, N, the conjugate base N prime, which is stabilized by resonance. And now this is the equivalent adjuncting structure. So the negative charge will be distributed between these two oxygen in equal proportion. So it will be minus up and minus up. Now the conjugate base O prime, the OMe group will operate the Placer effect and it will increase ultimately the negative charge density in benzene. So this negative charge density decreases this resonance of this conjugation of this negative charge, and that's why it is quite less stable and than the previous. And in the conjugate acid P, conjugate base P prime, which is stabilized by three equivalent adjuncting structure. So this negative charge will distribute between these three oxygen with equal proportion. So it will be 1/3 minus on each oxygen. So if we compare the stability order, when the charge distribution is much higher, higher the stability. So here the charge distribution is much higher, so the P prime stability order will be, so the stability order will be P prime is much higher stable than N prime. N prime is this, it is minus up in each oxygen, and then O prime is this because it is greater stable, higher stability order, higher stable than M prime. So the acidity order will be the same as the conjugate base stability. So the acidity order will be P greater than N greater than O greater than M.